Good day everyone. We are pleased to present our topic, Application of Chromatography in Food Safety, Detection of Food Additives and Contaminants. Chromatography is one of the most widely used analytical techniques in chemistry. It plays an important role in ensuring that the food we consume is safe, free from harmful substances and meet quality standards. Today, we will explain what chromatography is, how it works, and how it applies in food safety. First of all, my name is Melsiwena Resa Serifa Naundi, and my partner is Natalia Ramani. So, our presentation is divided into 4 main sections. First, we will introduce chromatography and discuss its principle. Next, we will explain the different types of chromatography. Then my partner will discuss its application in food safety, including the analytical method and sample results. Finally, we will conclude the importance of chromatography and list our references. So, what is chromatography? Chromatography is an analytical technique used to separate, identify, and sometimes quantify the different components in a mixture. It works because different substances travel at different speeds when they move through 2 phases called the stationary phase and the mobile phase. This technique is widely used in food analysis, pharmaceutical manufacturing, environmental monitoring, forensic science, and many other industries. History of chromatography. Chromatography was first introduced in 1906 by the Russian botanist Michael Tivek. He developed these techniques to separate plant pigments such as chlorophyll and carotenoids. The word chromatography comes from the Greek words meaning color and writing, because they separate pigments from colored bands. Since then, chromatography has become one of the most important techniques in modern analytical chemistry. Now, let's look at how chromatography works. The separation occurs because different compounds interact differently with the stationary phase and the mobile phase. Some compounds are more strongly attracted to the stationary phase, so they move slowly. Others are more soluble in the mobile phase, allowing them to move faster. Because of this difference, movement rates, the mixture separates into individual components that can be identified and analyzed. There are several types of chromatography. Paper chromatography is mainly used in schools and simple laboratory experiments. Thin layer chromatography or TLC is commonly used to identify compounds and check sample purity. Gas chromatography or GC is suitable for volatile substances such as gases and solvents. Finally, high-performance liquid chromatography or HPLC is one of the most accurate and sensitive techniques. It is widely used in food testing, pharmaceutical analysis, and research laboratories. In this presentation, we will focus on HPLC because it is commonly used to analyze food additives. Food safety is essential because the food we eat may contain substances that affect our health. These include artificial colorants, preservatives, pesticide residue, heavy metals, and other harmful contaminants. To protect consumers, laboratories use chromatography to detect and measure these substances accurately. For example, chromatography can detect pesticide residue in vegetable, identify artificial dyes in beverage, and analyze preservative in processed foods. Now, I will hand over to my partner who will explain one specific application of chromatography in food safety.
Thank you, Melsiwena. For this section, we will talk about application. Our selected application is the detection of artificial food coloring in soft drink using high-performance liquid chromatography or HPLC. Artificial food dyes are commonly added to improve the appearance of beverages and make them more attractive to consumers. However, if the concentration exceeds the permitted limit, it may pose health risks to sensitive individuals. Therefore, HPLC is used to identify the type of dye present and measure its concentration to ensure compliance with the food safety regulation. Now we will talk about theory behind HPLC. HPLC is a chromatographic technique that separates compounds based on their interaction with the stationary phase and the mobile phase. The main part of an HPLC instrument include a solver reservoir, pump, injector, chromatographic column, detector, and computer. The pump pushes the mobile phase through the column under the high pressure. As the sample travels through the column, different compounds separate because each compound interacts differently with the stationary phase. The detector then records each separated compound as a peak on the chromatogram. Now we will talk about methodology. It's about the analytical procedure. First, a beverages sample is collected and filtered to remove suspended particles. The filtered sample is then injected into the HPLC instrument. The mobile phase carries the sample through the chromatographic column. Inside the column, the food dye separates according to their chemical property. Finally, the detector produces a chromatogram and the retention times are compared with the standard solution to identify each dye. This slide shows an example of an HPLC chromatogram. Each peak represents a different food coloring. For example, tartrazine appears at approximately 2.4 minutes, sunset yellow at 4.8 minutes, and the brilliant blue at 7.1 minutes. The retention time helps identify the compound, while the size of the peak represents its concentration. A larger peak area indicates a higher amount of that dye in the beverages sample. Besides food safety, chromatography has many other applications. In the food industry, it is used for the quality control and contamination testing. In pharmaceutical industry, it ensures medicine are pure and safe. Environmental laboratories use chromatography to detect pollutants in water, soil, and air. It is also widely used in forensic science to identify drug and toxic substances. Chromatography offers several advantages. It is highly accurate, sensitive, reliable, and capable of detecting very small amounts of substance. It also produces fast and reproducible results. However, chromatography instruments are expensive to purchase and maintain. They also require trained personnel to operate the equipment and interpret the result correctly. In conclusion, chromatography is an important analytical technique used to separate, identify, and quantify substances in a mixture. Its application in food safety helps detect harmful additives and contaminants, ensuring that food products meet safety standards before reaching the consumer. Among the different techniques, HPLC is one of the most effective methods for analyzing food additives because of its high accuracy and sensitivity. Therefore, chromatography plays a vital role in protecting public health and maintaining food quality. These are the references used in preparing our presentation, including analytical chemistry textbook and peer-reviewed journal articles from the Google Scholar. Thank you for your attention. We hope this presentation has helped you understand the importance of the chromatography in the food safety. Thank you.